Alright guys, tonight you're going to see, I got 4 or 5 examples of some pretty complex problems. They're going to be the hardest ones you're going to have to do with these special angle pairs and the parallel lines and the transversals. This is as hard as it's going to get, but they're not difficult. They're just complex because there's a bunch of steps to it. We have to find, 4 or 5 relationships rather than just one. Okay? So, some of them are also kind of complicated because their pictures aren't the same as what we normally see. We normally see just 2 lines, 2 parallel lines, and a transversal, and that's it. And you'll see what I mean here. We're still in, again, those who like your titles, still in Unit 3 on angles, still on Section 1 on special angle pairs. Like I said, it's just some examples tonight. We're going to go through some more tomorrow in class. The idea is that you've already seen them, you've already got an idea of how to maybe tackle some of these more complicated problems, so we don't have to use class time for me to show you the basics, but you get an idea of it, and then we'll work tomorrow in class on them more. Alright, so for example, this is number 1. Find the values of x and y. I'll get your picture up here in a second. Values of x and y. Not Andy, but x and y. I know, my handwriting's still a mess. Get over it. Then find the measures of the angles. So here's your picture. You know what kind of shape this is? Does this look familiar at all? That's a rectangle box. Does the shape look familiar at all? It might. It is a trapezoid. We'll go over those more in a couple of units from now. We'll talk about all the shapes and all their names and how you know, but you may have recognized it. This angle up there in the top left is 2x. This one is y. This one is y minus 50. So it's like, wait, we haven't talked about shapes yet. Believe it or not, it's geometry in quarter 2, and we really haven't talked about shapes, but it's not really a shape. You've got parallel lines going on there, alright? So what I would suggest doing on a problem like this, alright, so everything up there is the problem. I'm getting ready to do some solving on it. I would take all of those lines and stretch them out. And things are going to look a lot more familiar that way. Now do you see your parallel lines going through and your 2 transversals? Alright? So we look at just the side with the x. Alright, so I'm going to focus just over on the left side here. I wonder if I can get a shade to cover that up. Oh, I can. Now, alright, let's focus on just this side. We have 2 angles happening here. We've got the 2x, which is what we need to figure out. We've got a 90-degree angle. So I have to think to myself, what's the relationship between those 2 angles? Oh, hey, they're same-side interior angles. And what do we know about same-side interior angles? They are supplementary. So when I'm going to do the math for this, I'm going to take my 2 angles, the 2x plus the 90, and that is going to equal 180 degrees. That's what it means to be supplementary. The 2 things add up to 180. It is now an algebra problem. All I got to do is do some solving. I subtract my 90 from both sides. 2x is equal to 180 minus 90. Oh, that's 90 again. Divide by 2. X is equal to 45 degrees. Not too bad. But what we got to remember is we have a whole other side. Aha. So I have another transversal. So again, I think to myself, all right, now these 2 angles that I'm dealing with, what type are those? Well, hey, they're SSIA again. We know SSIA are supplementary. So that tells me y plus y minus 50. I'm going to put that in parentheses just in case of some weird math stuff. That's going to equal 180 degrees. That's what it means to be supplementary. Again, the 2 things add to 180. I now have some algebra. Since this is a plus sign right there on the outside, I can just kind of drop the parentheses. Y plus y minus 50 equals 180. You got to remember how to combine like terms. I've seen this mistake happen a bunch of times, guys. This is not y squared. It is 2y. So 2y minus 50 equals 180. We add our 50. I'm assuming, by the way, that this algebra part is pretty easy for you. That's going to give us, what, 230 degrees. Scroll down a little bit, it's not right on the bottom. There it is. We divide by 2, and y is in fact 115. Right? So, we solved for x and y, but keep in mind what the problem asked us to do. It said, find the values of x and y, which we did, then find the measures of the angles. Right? So now we've got to go back to our original problem. But I'm going to list out what our angles were. So, we had a 90-degree angle right there. I'm going to forget about that because they already know what it is. They told us what that was. We had an angle that was 2x. We had an angle that was y. We had an angle that was y minus 50. Well, 2x, well, what was the value of x again? Yeah, it's way over there. X was 45. So we take 2 times 45 by substituting it, and that gives us another 90-degree angle. Y, we already know, is 115 degrees. Y minus 50 is 115 minus the 50, which is, in fact, has anybody got that number real quick? Yeah, I know, like you could, tell me over the video. It's 65 degrees. So this problem has 5 answers. It has what was x, what was y, and then the 3 angles. That looks really messy at the end, but if you need to go back to the beginning and kind of follow along where all those circles came from, do feel free. So this problem had 5 answers. That's what makes it complicated. Not the math, not the fact that they're same side interior angles or any of that, just how much it's asking for. Alright, problem number 2. So, example 2. So this one's going to give us a bunch of information ahead of time. First of all, it's going to say A is parallel to B. This is a bit of a new concept, slightly. When we label lines, we normally use like the 2 capital letters, the little symbol above it. If you actually use a lowercase, technically cursive letter, we'll actually label the line for you. You'll see that when I go to draw. They're also going to tell us that the measure of angle 1 is 2x plus 30 degrees, and that the measure of angle 2 is 6x minus 30 degrees. And they want to know, what is the measure of angle 3? They do also give us a picture, how kind of them. Cursive B, let's make that. That's terrible. Alright, you gotta pretend my letters are cursive. When they're typed up, it's really easy to do it in script font, so you can see they're cursive. But that little A and that little B are supposed to be cursive, and that refers to those entire lines. Here's where our angles are. So the question is, what is angle 3? Right? What makes this problem a little more complicated than what you've seen is that they give us angle 1 and angle 2. If I look at angle 1 and angle 2, those two are in no way, shape, or form any of the types that we know. They're on alternate sides, but they're not both interior or both exterior. They're not corresponding because one's on the left, one's on the right. So because they're not any of those, we kind of have to relate them in some other way. So I'm going to think to myself, well, all right, my projector just turned off. You guys can't see that because this actually records the video screen. So I'm going to pause this, go find me a better projector, and restart here in a moment. All right, so all you guys saw was a blip in the radar, and I had to go steal a projector from somebody because my projector is so much fun. All right, so we were trying to figure out how could we get from angle 1 and angle 2, how could we relate those, even though the two of them are not related to anything. All right, so I'm going to try and find a different relationship. I see angle 1 and angle 3 having a relationship. Not that kind of relationship, guys. Come on, stop your giggling. I know you're giggling at home. All right, angle 1 and angle 3, how are those related? Yes, absolutely, they are corresponding. What does it mean to be corresponding? What's that relationship? Yep, they are congruent. That's my ugly congruent symbol, right? So if those are congruent, so if angle 1 was 2x plus 30 degrees, angle 3 is also 2x plus 30 degrees. They gave us angle 2 was 6x minus 30. And now what do you see about angle 2 and angle 3? You notice anything? Yes, they're on a straight line, and since they're on a straight line, that makes them supplementary. Beautiful. So we're going to have a little fun with algebra here. We have 2x plus 30 plus 6x minus 30 is in fact equal to 180 degrees. Right? And if those two are supplementary, they add up to 180. I see my parentheses. I see nothing in front of either set of parentheses. I'm just going to drop the parentheses because there's nothing to distribute through or anything like that. I'm going to go ahead and combine some like terms. I see a plus 30 and a minus 30. Good news is those cancel out. I see a 2x and a positive 6x. So I'm going to get 8x equals 180. When I divide by 8, x equals, I'm trying to do that math in my head while I grab a calculator at the same time. You'll probably do this faster than me. X in fact equals 22.5. It is okay to get a decimal, guys. It really is. We don't often do it, mainly because I don't want you to get wrapped up in the decimals and getting confused by those versus the actual geometry. But it's okay to have a decimal. It really is. Question though is, did this problem ask for a measure of x? Did it ask how big x is? So if I go back to the beginning, I look, oh no, they wanted to know what is angle 3. So I go to my picture, since luckily I drew all over my picture, I know angle 3 is 2x plus 30. So the angle 3, so measure of angle 3 is 2x plus 30. I'm going to plug in my 22.5 for x. And the measure of angle 3 is 2 times 22.5. That's going to give us 45. And so the measure of angle 3, when we add those together, is 75 degrees. So this one's also complicated, not because it asked for 5 different answers, but because it did not give us a straight relationship from the beginning. I think those are a couple I'll give you for tonight. We'll go over a couple more in class tomorrow. Your secret for your candy for tomorrow. This time Miss King is the coolest person you have ever met. You say that, come in tomorrow morning. Before class, don't come in like during class at like 9 o'clock and you're going to get your candy. Before 8:45, Miss King is the coolest person ever. Candy is yours.